Consider the setup shown in the figure with mass m2 placed on an inclined plane and the mass m1 attached to mass m2 over the Pulleyan system is moving, and the coefficient of kinetic friction as 0.4. So we have to find the tension in the string. Okay, interesting. So this is the tension. This is the mass of the first block is 5. So the gravity force is 5g, of course. Um, the mass of the other block is 10 kg. So 10, and the theta is already 52.2. So the perpendicular component of the weight force is 10 cosine of theta, and along the plane, the force is 10 sine of theta, and the normal force is F sub n over here. Okay, and this is of course the tension. So we need to find that which pulling force is higher. It's 10 sine theta or the 5g. I mean, it's not just 10 sine theta, it's 10g as well. So we just to rewrite this along with 10g, 10g. So the value of 5g is somewhere around 5 times 9.8 is 49, and the value of 10g sine of 52.2 is somewhere around times 9.8 times sine of 52.2, 77. Clearly this one has a higher or greater pulling force, so the system will tend to move over this side. So let's say the acceleration is a over here and it is a up, so definitely the friction will act over in the opposite direction as in over here. Okay, so as in the equations of motion, the Newton's law is concerned. So T minus 5g is equal to m1a. M1 is 5, so that's 5a. That's equation number 1. Then we have 10g sine of theta minus T minus friction is equal to m 2a, where m2 is 10, so that's 10a once again. The friction is nothing but mu k times normal reaction, right? It's mu k, and mu k is already known to us as 0.4 times the normal reaction F sub n, that is equal to 10a. So this comes out as 10g sine of theta, which is 52.2 minus T minus 0.4 times, and the normal reaction will be same as 10g cosine of theta. So that's 10g cosine of 52.2, and that is equal to 10a. Let's call it equation number 2. Right, so I think what we can do is, since we are supposed to find the in fact, let's try to simplify the numbers, because there are too many numbers. It would be difficult for us to tackle. So let's solve these two, because all these two are constant. So that's 0.4 times cos of 52.2 and sine of 52.2 minus this value times 10 times 9.8. So this value comes out as 53.41 minus T is equal to 10A. Let's call this one as equation 2. So what we can do is we can divide both the equations, right? Because after all, we need to find the tension. So if we have to find the tension, we have to get rid of A, and division seems to be the perfect choice for it. So that's coming as T minus 5g over 53.41 minus T is equal to 5a over 10a is nothing but 5 over 10, which is 1 over 2. If we cross multiply, then 2t minus 10g is equal to 53.41 minus T. Adding T both sides, we get 3t, and adding 10g both sides, we get 53.41 plus 10g. So the value of T comes out as 3.41 plus 10 times 9.8 over 3, which is coming as 50.47 Newton. So that is the required tension. Thank you.